Hello, myself Shyamalatha, faculty at Silver Hills Public School, KOZHIKODE, Department of Mathematics. Let us look into a new chapter, Lines and Angles. In this session, the following topics will be discussed: angles and some important angles, special pairs of angles, transversal, angles formed by a transversal, and properties of parallel lines cut by a transversal. After this session, you will be able to define, illustrate and give examples of special pairs of angles. You will be able to identify the different types of angles made by the transversal cutting two lines. And also you will be able to solve and analyze geometrical problems. Now, what is an angle? In geometry, an angle can be defined as a figure formed by two rays meeting at a common end point called the vertex. Now, look at the figure. The figure has got two rays, ray 1 and ray 2. These two rays, they meet at a common point called the vertex. So, when these two rays meet at a common point, they form an angle. Next, let us study some important angle. The first one is the 90 degree. When do we get 90 degree angle? We get 90 degree angle when a vertical straight line meets a horizontal straight line. You get 90 degree, it forms L shape. Look at the clock, the two arms, they form 90 degree. The distance between the two arms gives you L shape, which is equal to 90 degree, and this 90 degree is also called right angle. Next is 180 degree. When do we get 180 degree? When we add 90 plus 90. Sum of 90 plus 90 gives you 180 degree. So, it forms a straight line. The best example for that is your protractor. The protractor has measurement starting from 0 to 180. It forms a straight line. It is semicircle in shape. Next comes 360 degree. When do we get 360 degree? When we add 180 plus 180, that is two semicircles, you get a full circle. So, 360 is also a complete angle. The measure of full circle is 360 degree. So, a complete circle measures 360 degree. Next is special pairs of angle. First one is the complementary angle. What is a complementary angle? Two angles are said to be complementary if the sum of the measures is equal to 90 degree. In the figure, you can see two angles. One of the angle measures 60 degree and the other angle measures 30 degree. When you add 60 plus 30, the sum is equal to 90 degree. So, we say that 60 is the complement of 30. Similarly, 30 degree is the complement of 60 degree. The condition is that the sum should be always equal to 90 degree. Only then we call them as complementary angles. Let us look into an example. Are the following angles complementary? Figure 1, you have two angles. One angle measures 75, the other angle measures 25 degree. When you add 75 plus 25, you get 100. It is not equal to 90. Hence, we can say that they are not complementary angles. But look at figure 2. When you add 27 plus 63, the sum is equal to 90 degree. Hence, they are complementary angle. 27 is complement of 63 and 63 is the complement of 27. Next, let us move on to the next type of angle, that is the supplementary angle. Two angles are said to be supplementary if the sum of their measures is equal to 180. The sum of two angles. In the figure, you can see one angle measures 120 and the other angle measures 60 degree. When you add 120 plus 60, the sum is equal to 180. Such type of angles are called supplementary angle. So, 120 is the supplement of 60 and 60 is the supplement of 120. Let us see an example for supplementary angle. Figure 1 has got two angles. One measures 140 degree, the other one measures 55 degree. When you add 140 plus 55, you get 195. This is not equal to 180. So, we cannot call them as supplementary angles. Let us look at the second figure, figure 2. In figure 2, you see one angle measures 60 and the other angle measures 120. 60 plus 120 is 180. So, we can say that they are supplementary angle. 60 degree is the supplement of 120 and 120 is the supplement of 60 degree. Adjacent angles. When two angles lie on the opposite side of a common arm and have a common vertex, they are known as adjacent angles. That is, look at the figure. This figure has got two angles. One angle 1 and the other one is angle 2. These two angles are sharing one common arm. The common arm here is LT. So, when two angles share one common arm and if they have a common vertex, such type of angles are called adjacent angles. Next is the examples of adjacent angles. Look at the clock. The clock has got two arms. Apart from that, it has got the seconds hand. This is forming adjacent angle. Next is a scissor, angle A and angle B. They are adjacent angles. Next is the example of a pizza. Linear pair. What are linear pair? Two angles whose non-common sides form opposite rays, they add up to form 180 degree. Two adjacent angles whose non-common sides form opposite rays, they add up to form 180 degree. In the figure, you can see that they are adjacent angles, but the condition here is the non-common OA and OC, they should form opposite rays. And when you add those two angles, the sum has to be 180 degree. Only then you can call them as linear pair. When the sum is equal to 180, you call them as linear pair. 40 plus 140 is 180. Hence, they are called linear pair. Examples of linear pairs of angles. A book which is open wide forms linear pair of angles. Similarly, a chopping board, you can see two angles. These two angles, they form a straight line. The sum should be equal to 180 degree. Next is vertically opposite angles. When two lines intersect, opposite angles are formed. You can see that these are the two lines. When two lines intersect, each pair of angles formed without any common arm are called vertically opposite angles. There is no common arm here. They are just forming opposite angles. They are called as vertically opposite angles. You get that these angles when two lines intersect. Examples for vertically opposite angles. Look at the wings of the fan. You can see vertically opposite angles. Here hourglass. Here also you can see vertically opposite angles. Similarly, the board, railway crossing board, it gives you vertically opposite angles. Find the value of x, y, z in the following figure. Two lines, they intersect, out of which one angle is given, the others are x, y and z. How to find the value of x, y and z? We know that vertically opposite angles are equal. So, angle x will be equal to 105 because they are vertically opposite angles. So, we can write x is equal to 105 degree and y plus 105 should give you 180. Why is it y plus 105 is equal to 180? Because they are linear pair. It is a straight line. So, sum of y plus 105 should be equal to 180. So, y plus 105 is equal to 180. Y is equal to 180 minus 105. Therefore, y is equal to 75 degree. When y is 75, z also has to be 75 because they are vertically opposite angles. Vertically opposite angles are always equal. So, x is 105, y is 75, z is also 75. Next, let us study about the transversal. What is a transversal? Transversal is a line that cuts two lines at two distinct points. You can see two lines here and this red line which cuts the other two lines are called the transversal. It is called the transversal. When a transversal cuts these lines, many angles are formed. Okay. So, let us see which are those angles in detail. Angles formed by a transversal. Interior angles, interior alternate angles, exterior angles, exterior alternate angles, corresponding angles and vertically opposite angles. Let us study them in detail. First one is the interior angle. The word interior means it is inside. Look at the angles which are inside the two lines. When a transversal cuts two lines, line L and M, P is a transversal and the other lines are L and M. When the transversal cuts the line L and M, you get four interior angles. Interior means it is inside the two lines. Such type of angles are called interior angles. If it is inside the two lines, then it is called interior angles. Next is interior alternate angles. Interior alternate angles means opposite angles, alternate angles. The alternate angle of 3 is 6. Both are interior angles. Similarly, 4 and 5, alternate angle of 4 is 5. They are called interior alternate angles. Interior because they are inside, alternate they are opposite. Next comes the exterior angle. What is an exterior angle? Exterior again means outside, outside the two lines, outside the line L, outside the line M. You can see angle 1, angle 2 which is outside, similarly angle 7 and angle 8 which is also outside. Such angles which are outside the line are called exterior angles. Next is exterior alternate angles, that is opposite. Now, the alternate angles which are outside, they are exterior and they are alternate, x and x, y and y, they are exterior alternate angles. Next comes the corresponding angle. What is corresponding angle? The pair of angles on one side of the transversal, of which one should be an exterior angle and the other one should be an interior angle. Now, these two are the lines and T is the transversal. The pair of angles on one side of the transversal. So, the angles on one side, this side, and the angles on the other side, and the pair should be, one should be an exterior angle, the other one should be an interior angle. Let us see that. Now, top left, these two form corresponding angles. They are on one side of the transversal, out of which one should be an exterior angle, the other one should be an interior angle. Next comes the other side, on the other side of the transversal, one above, one below. So, these two are called corresponding, they are one pair of corresponding angle. Bottom left, this is one pair of corresponding angle. Next, bottom right, one is interior, one is exterior. They form another pair of corresponding angles. Angle 1 is equal to angle 5, angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7, angle 4 is equal to angle 8. These are called the corresponding angles. One should be an interior angle, the other one should be an exterior angle, and they should be on one side of the transversal. To make it clear, these are the corresponding angles x and x. This x, one is exterior, the other x is interior angle. Similarly, y, one y is exterior, this y is interior. Z is interior, exterior, interior, exterior. They are the pairs of corresponding angles. Now, vertical opposite angle. When two lines intersect, they form vertical opposite angles. So, this transversal, when it cuts these two lines, you get vertical opposite angle. The vertical opposite angle of 1 is 4, 2 is 3, 5 is 8 and 6 is 7. So, the vertically opposite angles are 1 and 4. They will be equal. Similarly, angle 2 will be equal to angle 3. Similarly, 5 will be equal to angle 8, angle 7 will be equal to angle 6. What are parallel lines? If two or more lines on a plane do not meet each other, however far they are extended, they are called parallel lines. See, now these are the two lines, line M and line N. We can call them as parallel lines provided they do not meet each other. The distance between these two are maintained throughout. They never meet each other even if they are extended. Such lines are called parallel lines. The best example is the railway track. They maintain same distance and they never meet each other. Such lines are called parallel lines. Properties of parallel lines cut by a transversal. When a transversal cuts a parallel line, let us see the different properties. The first property is, if two parallel lines are cut by a transversal, the alternate interior angles are equal. Alternate interior angles, the angles which are inside the parallel line, that is 4, 3, 5, 6, they are interior angles, and alternate angles are 4 and 6, 3 and 5. So, 4 should be equal to 6, similarly angle 3 will be equal to 5. This is property 1. Property 1 says, if two parallel lines are cut by a transversal, the alternate interior angles are equal. Next property, property 2 says that if two parallel lines are cut by a transversal, alternate exterior angles are equal. The exterior angles, which are the exterior angles here? 1, 2, 8 and 7, they are not inside the parallel line, they are above or outside the parallel line. So, the alternate exterior angles are 1 and 7, 2 and 8. So, 1 will be equal to 7 and 2 is equal to 8. So, once again, if two parallel lines are cut by a transversal, the alternate exterior angles are equal. This is the second property. Moving on to the third property, if two parallel lines are cut by a transversal, the corresponding angles are equal. Now, the corresponding angles, angle 1 and angle 5, that is one pair. Next, angle 4 and angle 8, next pair. 2 and 6, one pair. 3 and 7 are the next set of corresponding angles. These angles will be equal if they are parallel lines. So, whenever a transversal cuts parallel lines, the corresponding angles has to be equal. Angle 1 is equal to angle 5, angle 4 is equal to angle 8, angle 2 is equal to angle 6 and angle 3 is equal to angle 7. Next is, if two parallel lines are cut by a transversal, the interior angles on the same side of the transversal are supplementary. Now, in the figure, line L and line M are parallel lines and D is the transversal. The interior angles are 4, 3, 5 and 6. The property says that the angles inside the interior angles which are on the same side of the transversal. Which are the angles on the same side of the transversal? It is 4 and 5 and the other one is 3 and 6. These are interior angles and they are on one side of the transversal. When we add 3 plus 6, these two are interior on same side of the transversal. When we add 3 plus 6, the sum has to be 180. Or when we add 4 and 5, that also has to be equal to 180 degree. That is the fourth property. The fourth property says, if two parallel lines are cut by a transversal, the interior angles on the same side of the transversal are supplementary. That means the sum has to be 180. I hope all of you enjoyed this session. Thank you and have a nice day.